Hey Esther, I just thought this might be a little bit quicker to go through it this way. So you have the basic thing right. I'm not sure what happened here, but it looks like this is not the right answer, this 0.9212, but you have the right steps. So I'm wondering if it's a rounding issue or just typing it in incorrectly. So what I'm going to do is I'm just going to show you how to do it in Excel instead of a calculator, even though it's the same idea, just to make it a little bit easier. I have a feeling it's a rounding issue though, because this is very close. So let's go back to the problem right here. So we have these 5 squash. Here's the weight. Here's the sample mean. They give it to us. And then the standard deviation for the population. Remember when it's sigma instead of S, that means that's the population standard deviation. And that's why we can use Z instead of T here. If we didn't know this population standard deviation, we wouldn't be able to do that. So let's go. What I went ahead and did is just typed this in. I'm going to delete that just to show you. So I went ahead and typed in the data. Even though it gives you the sample mean, I always like to just calculate. So I went ahead and put an N is 5. The mean is the average of these 5, and the standard deviation from the population is given as 1.25. So really quick, I'm just going to go to the lesson that I put out earlier this week. I don't know if you've looked at these. I do think they're a really good reference tool. In there, I have the critical values for the most common confidence levels. You already know this since you found it, but just in case, I want to make sure you knew where to reference this. So our Z star is going to be 0.1645, and right here we have that the margin of error is that critical value times sigma divided by square root n. So really quick, what I'm going to do is just type it in as the function. So here we have 1.645 star. I'm going to do open parenthesis, our sigma divided by square root of our n, close parentheses, and we get 0.9195. So you got that 9212. That's why I'm thinking there's a rounding issue. So really quick, I thought what might be helpful is to find, you got a 0.56 for this part, sigma divided by square root n. So let's go and do equals sigma divided by square root of n. So we do get 0.559. So you do get 0.56. I think because you rounded there when you did your margin of error, that might have impacted your number and why you're getting a different number. I do recommend doing it this way in Excel. It's super handy to type in these formulas. What's great about this, not only is it handy, but let's say you have another data set, you can just erase some of these things, like for example, put in the new data set here, update your mean, your n, and your standard deviation, and it'll automatically calculate that. So let's go ahead and do our lower bound. That's going to equal our sample mean, subtract our margin of error. And we're going to do our upper bound. Oops. And that's going to equal our sample mean plus our margin of error. So that gives us these numbers. Let's go back and check in Zybooks. Let's do this. So that was the third one right here, the 90%. So we need to use 3 decimal points. So we're going to do 15 point, oops, let me help if I put my square bracket, 15.580, comma 17.420, because that 5 rounds that 9 up, which rounds that up. So 17.420. Oops, check answer. That's correct. All right, again, I do have a feeling it was a rounding error at this point. So even if you were to not do this all in one step like I did here and break it up like you did, you definitely need to take it out a few more decimal places to make sure you avoid that rounding error. So I hope that helps with that one. If you have any other questions, let me know.